Welcome to another unit in business mathematics. This time I'm going to talk about how we can determine extrema of functions with more than one variable, which is actually not this hard if you already know how you can determine extrema for functions with just one variable, because we are more or less doing the same thing here. So if we go here and consider which type of scheme we follow. So the first thing is we calculate the first and second derivatives regarding all possibilities. So we have, if for example we have a function with just two variables, two first derivatives and four second derivatives. Then, similarly to what we did when we worked with just one variable, we set all first derivatives equal to 0, solve this resulting system of equations, and get all possible extrema. In this case, well, I put linear in brackets because usually this is not linear. If it's linear, it's pretty easy, pretty straightforward. If it's not linear, usually it works out fine if you follow these three advices. First, try to solve one equation for one of the variables, insert into all the others. Usually gets rid of one of the variables, then you could continue. Or, if it looks easier, try to solve two equations for one of the variables and set them equal. One important aspect, which is here even more important than if you calculate extrema for functions with one variable, is before you divide by one variable, always check what would happen if this variable were to be 0. You should also do this with one variable, but here actually becomes more important because you can get even more solutions than just the one where only, for example, the x is 0. Here, this could actually be more, so take special care to always differentiate between this variable is 0, this variable is not 0, and only if it's not 0 can you divide by it. Okay, once you found all possible extrema, we need to check whether they are maxima, minima, or saddle points. For this, we actually have two possibilities. Here in this case, I only list the approach which you use if you have but two variables. If you would have more than two, there's still a version of what I presented here for even higher dimensions, but it's pretty hard to actually write this down. So I restrict myself to this. For those of you who already heard about eigenvalues, you can also determine the eigenvalues and then based on the eigenvalues determine whether you have maxima, minima or something else. If you only have positive eigenvalues, you have a minimum. If you only have negative eigenvalues, you have a maximum. If you have positive and negative eigenvalues, then you have a saddle point. If one of the eigenvalues is 0, then no answer is possible at this point. Something similar we have here as well. So the first part, we are always considering basically the matrix with all our second derivatives. And first off, we calculate its determinant. So basically the 1 to the upper left times the 1 to the lower right minus the 1 to the upper right times the 1 on the lower left. If this is positive, then we actually can get a minimum or a maximum. If it's negative, then it could be a saddle point. Whether it's a maximum, minimum, or a saddle point is determined by the value on the upper left. So if it's a potential extremum, check whether the value on the upper left is negative, which would be then a maximum, or positive, which would mean it's a minimum. If the value is different from 0 and we have a negative determinant, we have a saddle point. If any of these two expressions become 0, it's not possible to say anything at this point. So you might get like a ridge, which is all maximars, or like a trench, which is all minima. So this would mean if one of the variables is 0. So you don't have a clear maximum, minimum, or even a saddle point. Well, that's already everything there is. So that's a way to actually determine, do we have maxima, minima, saddle point, or, well, something where we cannot be really this sure, which means we have like a trench, ridge, or something higher dimensionally equivalent. Well, as I said, that's all there is. So I say goodbye and see you next time.